Fine, guys. Let's have some quick recap. Okay. So what we yeah. So what we studied, guys. So we are having a something called as point estimate, right? A point estimate. Fine. So what is this point estimate? Point estimate is an estimation of a population parameter. Okay, because we cannot have the whole population data available all the time. Fine. So we would like to have some other value which will act as a representation of the population parameter. Okay. But now when I say it's a representation of the population parameter, fine. Any parameter, for example, population mean, population standard deviation, population variance, any particular population related parameter, fine, we can have a estimation of that. Okay, we can have a estimation of that. How you are going to have the estimation? From the sample. Okay, so if you remember from the central limit theorem, fine, from the central limit theorem, what we studied, guys, just to give a recap of even that, if at all you are having a population, okay, with mean equal to mu, fine, and in that you have something called a sampling distribution. Okay, that means what? Taking multiple samples from the same population and calculating the mean of each and every of this sample. Fine. These whole samples are called as sample mean or sampling distribution. Okay. And what we also understood that this sampling distribution will follow a normal distribution curve. And the most important thing for now is the mean of this sampling distribution. That means the mean of this sample distribution will be almost same as the population mean. Okay, and the variance is equal to the population variance by n is the sample size. This is what we have studied in the central limit theorem concept. But here we also told that the mean of the sample mean is almost equal to population mean. That means what? This is acting like a point estimate. This is acting like a point estimate. That means in the place of population parameter mu, we would like to use the sample parameter because these are almost equal. And that's the reason we can call this mean of the sample mean is acting as a point estimate of the population mean, which is mu. Okay. And yeah, are we good with this, guys? Are this concepts still with you, or did they just disappeared? Okay, so I hope you remember these concepts. Fine. So now coming to this particular point, when we are saying the mean is almost equal to mu, but how much equal to? Whether it will be exactly equal or less than or greater than, that is the point we would like to discuss. Okay. So next, what we have seen, we have seen a point estimate is a rough idea of population. It's just a rough idea. That means it is prone to errors. Okay. That means taking multiple samples to get improved estimates may not be feasible. So that is the reason. So instead of just saying one particular point estimate is equal to population mean, which might be equal to or might not be equal to the population mean. Okay, instead of going ahead with only one point estimate, what we thought is to give a interval. Okay, to give a interval. Fine. So what is the interval? So it is saying a confidence interval is a range of values above and below the point estimate that captures a true population parameter. Okay, so I don't want to give only one population sorry, one point estimate. Okay, so because this may be equal to, may not be equal to, I'm not 100% sure. But instead of giving one point, I'll just give a range. How you will get the range? So you will add some values to this point estimate. That will be the upper end, and you will separate some values from this point estimate that will create the lower end. Okay, so now this became a range. Fine. And this range is called what? This range is called confidence interval. Okay, this is interval. You got the interval. Fine. And also we understood that each confidence interval should have a confidence level associated with it. Okay, should have some confidence level associated with it. That means what? If you want to have a 95% chance of capturing the true population with a point estimate and corresponding confidence interval, you would like to set your confidence level to 95. Okay, that means for each and every confidence interval, there should be some confidence level. And what is the relation between this confidence level and confidence interval? Higher confidence level result in wider confidence interval. That means what? As I said the other day, the example is if the point estimate is 84, okay, so if the point estimate is 84, fine, that means marks, okay, you are just guessing how many marks you will be getting in an exam for total score of 100, fine. So if the instead of saying exactly 84, okay, so if I ask you, hey, are you going to get exactly 84, you will not be sure, okay, but if I give you a range 83 to 85, you are a bit confident. But if I increase this width, you see I'm increasing this width, okay, obviously your confidence also increases. Why? Because when the width is increasing, there are more possibilities, so there are less chances for you to fail, because the more opportunities are there. Okay, somewhere in this range definitely your value is going to be present, so you can be more confident. But if I keep on decreasing the width, okay, if I keep on decreasing the width, fine, so your confidence will decrease, your confidence will decrease. Agree? So as you are that's the reason higher confidence, that means see here, this is a higher 99% confident, higher confidence levels, okay, higher confidence level results in wider confidence intervals, okay, wider confidence intervals. That means if the confidence level is increasing, the width of the confidence interval will also increase, so it's become width, okay. But as you decrease the confidence level, the width of the confidence interval will also decrease. Okay, that's what we have studied, right? So let me know, are we good till this point? Any doubts here, any clarifications, any one of you?
Clear, sir.
Okay, fine. So after that, what we studied is, okay, now since we understood that a confidence level and confidence interval will be interrelated, and also we are saying the single point estimate will not be exactly equal, it is prone to error. So what we are going to do, we need to create a confidence interval. So how we are going to create a confidence interval, that also we have seen. So confidence interval will be created, okay, by doing this, okay, point estimate plus or minus margin of error, okay, point estimate plus or minus margin of error. And what was the margin of error? See, the margin of error is based on the desired confidence level, okay, the spread of the data and the size. The way you calculate the margin of error depends on whether you know the standard deviation of the population or not, okay. So now this was a important point over here, okay. So now, yeah, so if you see here, if at all you know, yeah, so yeah, the last concept in our last class was how to calculate this margin of error. Okay, so if you know margin of error, you will take that margin of error and you will do plus and minus of this margin error from the point estimate. Okay, that will create the confidence interval. Okay, that will create the confidence interval. Okay, now how to calculate this margin of error? So there will be two ways. If you know the population standard deviation, okay, if you know the population standard deviation, you will have one formula. If you don't know the population standard deviation, guys, there will be another formula. Okay, so now if you know the population standard deviation, fine, so what will be the formula? So as I said, if you know the standard deviation, the formula is just z into, okay, now what is z? Z is a critical value, okay, we will be seeing, okay, so a value z into standard error. Now what is standard error? Standard error is nothing but it is a square root of sampling distribution variance, okay, sampling distribution variance. Now, what is the sampling distribution variance? If you see over here, we are having the sampling distribution. If the population distribution variance is rho square, the sampling distribution variance is rho square by n. Okay, it is the rho square by n. Agree? So that's the thing we are using over here. Okay, square root of rho square by n. Okay, that is equal to z into rho by square root of n. Fine. Why are we using this formula, guys? Why are we using this formula, and how are we getting? Because from the center limit theorem also, it is saying from one sample, if you take multiple samples, you will get this formula. In our case also, to we are calculating this margin of error, and where are we going to use this margin of error? With the point estimate. How you are going to get the point estimate? You are going to get the point estimate by from the multiple samples. Okay, so just to go back one more step again, see, if you remember the point estimates, what we are doing. So we are taking multiple samples. Okay, see, from input or random dot choice from the population of from population ages. Okay, 1000 sample values you are taking. Okay, so 1000 sample values are taking, and if you're checking, the population ages and the sample mean ages are almost similar. Okay, so now this sample ages can be called as a point estimate. Similarly, what we have done, I think we have also considered taking multiple samples. Random size equal to this. Yes, here. So if you remember, I showed you the center limit theorem example, that even though if the actual true population is something like this, which is not normal, if you take sufficient, like if you're taking 200 samples, okay, each of size 500 from the population data, okay, the mean and the distribution of the resulting sampling distribution will be normal distribution. Okay, now this mean will also act as a sampling, the point estimate of the population mean. Fine, the same concept I'm trying to use over here. Okay, so that's the reason, since we'll take multiple samples, okay, and create the point estimate. Fine, so we can use this formula. Okay, so we can use this formula because it will abide by the center limit theorem rules. Fine, so we got the standard error. Okay, we got the standard error, and when you replace, you will get this one. Fine, so now finally we have the if the population is known. Okay, if the population is known, sorry, I mean if the population variance is known, okay guys, then the formula is, okay, then the formula is, observe this guys, this is very important, point estimate. That means in our case, what is a point estimate? Sampling mean is a point estimate. Okay, so it will be x bar, okay, plus z into, okay, z into alpha by 2, and same thing, z at alpha by 2. Okay, we'll see what is this, into rho by n. Okay, simple formula, don't get confused. The same concept what we are studying from the last class, that with point estimate, you will add some values and subtract some values, which is called margin of error, so that to create the confidence interval. That's it. Okay, I hope that till that point you are clear. Okay, just 2 steps. First, you need to know the point estimate, calculate the point estimate, done. Calculate the margin of error, done. Do plus or minus between these 2 values, done. That will create you the confidence interval. Okay, now what is our point estimate? See, point estimate, margin of error. Now what is our point estimate? Point estimate is our sampling mean. Okay, and that is x bar. Okay, and what is margin of error? Margin of error is z into rho by n. Okay, you are doing plus or minus Okay, plus or minus z into rho by n. But what is this alpha we are going to see? Okay, but this formula is sampling mean, which is also point estimate, plus or minus z into rho by n. This is when you know the population variance. Why? Because in this formula you need to know each and every value. What is this x bar? X bar is sample mean. Okay, x bar is sample mean. Okay, and here rho is population variance. So that's why this will work only when you know the population variance, guys. Okay, the actual population variance, if you know, this will work. Okay, and n is sample size. Okay, this n is sample size. Okay, and what is this z? Now z is the, okay, we'll see. Now z is the, it's called critical value. Okay, it is called the critical value. Fine, and we need z at alpha by 2. Okay, so we need z at, z should be calculated at a value called as alpha by 2. Okay, which means for a, for a particular confidence level we have a particular alpha. Okay, and from this alpha, okay, from this alpha you will get alpha by 2. Okay, and then we can go to the z tables and get the z critical value. Okay, so this step is not clear to you, that I understand, that we are going to see, but just don't worry about this, we are going to see it just in a moment. But coming to this formula, okay, let me know if this formula is clear. Okay, so point estimate plus or minus standard error or margin of error. Okay, so that's how we are. So nothing new in this. You know, if you, since you are taking multiple samples, let's say like in the, like this example, you are taking 200 samples, so you will have a sampling distribution, and for that all the sample means you will calculate a mean, which is called the sample mean. Okay, so that is x bar, and number of samples how many you are taking, that will be n, and population variance, actual from which population you are taking all these samples, that population ka variance is this, and z is we are going to see plus or minus. Okay, once you know, once you solve these values, you will get a range, and that is a confidence interval, guys. And what is the importance of confidence interval? Why are we calculating confidence interval? So that somewhere in between that confidence interval, the actual population mean can be captured. Guys, are you getting? Because now I have doubt. Like, I guess understanding. Let me know, because I need to know whether you guys are on track or not. Or let me know where did you lose the track. Or yeah, Meghna, now like, do you understand like why we are calculating the confidence interval?
Yes, sir.
Why?
Because it gives the point estimates of true population.
Point? No. Point estimate we already have, right? Why we want it from the confidence level? We already have the point estimate. From that point estimate only, we will get confidence interval. Then why confidence interval will again give the point estimate?
It gives the mean of total population.
Yeah, yeah. See, try to understand. See, guys. Okay. Yeah, what you said is right, but Srisha, are you getting the concept? Yeah. So, see, Srisha, see, also, Meghana, see, first of all, first of all, there is a population. Okay. The basic idea I'm saying you. Okay. There is a population. Agree? This population will have its mean called as mu. Agree? Now, you don't know what is this mu. Okay, guys. You don't know what is this mu of this population. Okay. The idea is to calculate this mu. Are we good till this point?
Yes, sir.
See, okay, try to understand. There is a population, complete whole data, which will obviously have a mean. Fine, because you cannot have the whole data available. This knowing this mean is almost impossible. Okay. Now the point over here is, okay, because we humans are smart enough, so what we derived is, even though we don't have the whole population, that's fine. We don't worry. We will take multiple samples from this sample 1, sample 2, okay, like that. We'll take 200 samples, for example. Okay. And what we are saying, for each of this, it will have a mean. Okay. Mean 1, okay, mean 2, like that, mean 200. Okay. These are all means. Fine. And for all these 200 also, there will be one more mean, that is a sampling mean. Okay. Getting? Because this sample one is will have, let's say, 500 points it is taking from this whole 1 crore points. Sample one will take only just 500 points. Like that, every sample will take 500 points. For those this particular 500 points, it will have a mean. For its own 500 points, it will have one mean. Like that, 200 samples will have 200 means. Now, forget about the samples. You are having just 200 means. That means 200 points. Mean is just a point, right? Now, for this 200 points also, you can calculate again one mean. That is the sampling mean, X bar. Are we good till this point?
Yes, sir.
Right. So now, according to the central limit theorem, we are saying now, but now, Megan, what is our goal till here? Actually, what we want to do over here? What we want to find out?
Mean, sample mean.
Sample mean?
That is, sorry, X bar.
X bar? X bar we already, X bar we can directly find out,
All
right?
the samples, mean of all samples.
Correct. Mean of all samples, you got X bar. X bar, we don't need to find out X bar directly. I mean, our goal is not to find out X
It
bar,
is
right?
equal to mean of population.
Correct. So this will be equal to, now what is mean of population?
Mu.
Correct. Okay. So our goal is this one, to find out this, because X bar we can directly calculate by manually, right? Because take 500 samples, calculate the mean, 200 means you will get. Again, find out the mean of this, mean of all these 200 points. That you will get X bar. Okay. X bar, calculating X bar is not tough. But now, why we are doing all this part, we are doing all this drama to estimate this mu. What is the actual population ka mu? Agree? Clear till this point?
Yes, sir.
Okay. So now clear. So now whatever the sampling mean you are going to get over here. Okay. So that is x bar. Now this part, see, if at all we say this x bar is 100% equal to mu, there ends the matter. Fine. Because you don't need to do anything else, because if x bar is exactly equal to mu, obviously every time take some samples and you will get mean of this and you will get x bar. Okay, instead of using mu, use x bar. Now this is exact point. It is not estimation, it is exact value you are getting. Wherever you want to use mu, directly go and use x bar. Fine, if this is the case, but that is not the case, right? Because since these are actually samples, these are not the actual data. We are taking the samples and we are doing some estimation. Agree? So now this x bar is just an point estimate of mu. It is not exact value. It's just a point estimate. That means what? For example, if this me equal to 50, for example, okay, this will be somewhere around that. It will be very close, but somewhere 49 or 51 or 48, something like that. Almost equal to mu. Good till this point?
Yes, sir.
Fine. So now the next point is, we are saying, okay, it is not exactly equal. Okay. But now, is there any way? Okay. Is there any way so that I can capture this true population? Okay. So our goal is to capture this true population, guys. That is a fundamental goal. Okay, if your actual sampling mean, if it is, in case if you are lucky, if it is exactly equal to mu, then no need of any extra work, there ends the matter. But most of the case it's not equal to exactly, it is somewhat similar to. Okay, that's why what we are doing. Okay, because see, try to understand the problem here is, if at all our sampling mean is 48 and if at all our mean is 50, okay, it is a very good point estimate, but still there is a great difference. Two might be a small difference, it might seem to be, but in calculations, okay, it might create much far differences. Okay, just if you calculate 2 into 100, it will give 200. Okay, just as an example. Fine. So even though point estimate is great, okay, but still we need something better. We actually need to know where this guy is sitting. Okay, whether this guy is below 48 or above 48, we don't know. Okay, because I'm assuming this is 50, but I also don't know how much this value, but I know our point estimate x bar from this calculation, I got it as 48, guys. Okay, I got as 48. So I'm estimating that mean will be very near to this 48. I don't know this 48. Later you might be knowing 50, but as of now you don't know, guys. For example, as of now you don't know, because if you know this mu, then why we need to do all this? No, right? So we just know this x bar. Let's say it is 48. Now once we know this 48, right? So now I will assume that mean, this actual population mean is somewhere near this 48. I don't know where, but it is somewhere near. It might be greater than this, less than this, or very near, or very somewhere far, somewhere, but it will be somewhere around this 48. Okay, my goal is to find out that. Getting till this point?
Yes, sir.
Okay, clear. Now that's the reason, because it is near to 48, that means it can be greater than 48 or less than 48. I don't know, right? So that is the reason what we are going to do. We need, so that is when we understood single point estimate is not going to do our job. We want an interval. Okay, we want an interval. And for example, if you ask me, hey, when are you going to come to my party? Okay, if I say exactly, I'll come at exactly at 8. Okay, it might not be possible, right? Now 8 is a point estimate, it is single point. I'm saying I'm going to, I'll be there at exactly sharp 8. If I come 8, it might not be possible. So that's why what we'll say, I'll come around some around 8, I will say. Okay, you getting? I'll say around 8. That means somewhere around 7:50 to quarter to 8 to 8:15 in that half an hour time, I will be over there. That I know because there might be multiple factors affecting, right? Due to traffic or right or some other reasons because getting ready might be late or due to some office work. Some a number of factors might affect that. So that's why I cannot give exact value. So I will say around that. So some value less than 8, some value greater than 8. That means quarter to 8 to 8:15. Between this time, I'm sure. Agree? I'm sure I'm going to get. Similarly, here also point estimate also 48. I'm not sure, but around 48 I'm sure. So that means to get some values. So this will be somewhere over here and somewhere over here. This range is called. What is this range is called? Can someone tell me? Any idea what from point estimate what range we are getting? Fine. So this range is called confidence interval, guys. Okay. So we have seen just now. This range is called confidence interval. Okay. From point estimate, we are going to confidence interval. How you are going to confidence interval? So that's the reason from point estimate, you need to add something called as plus margin of error and minus margin of error. Okay, that means for example, margin of error is 3. Okay, there is some formula, margin of error is 3. And what is our point estimate? 48. So 48 plus 3 will be 51 and 48 minus 3 will be 45. Okay. So now instead of me saying, hey, this 48, which is a point estimate, is exactly equal to what was this mean? 50, right? So instead of saying, hey, this point estimate is exactly equal to population mean, okay, which might be wrong. Now, but I can say, I don't know whether this exact point estimate is equal to population parameter mu or not. I am not very sure. But instead of that, I'll give you a range, which is called confidence interval. Okay. This confidence interval, see, this is a confidence interval. I'm saying between 45 to 51, you are able to catch the population mean. That is sure. That is my point. And that is also possible because if you see 50, see somewhere between 45 to 51, you will have this population mean. You are able to capture our guy, this mu, we are able to capture here in this confidence interval. Getting?
Yes, sir.
Is this clear? Really?
Yes, sir.
Clear, right? Fine. So now that is the reason you want the confidence interval, which will capture somewhere the population mean. Okay. Now this confidence interval, as I said, confidence interval could be varying. Okay. You can vary this. Okay. You can increase or decrease this. Fine. So now going back here. So what we studied confidence interval, and each confidence interval will have some confidence level. Okay. Each confidence interval will have some confidence level. Okay. And we also saw the relationship between the confidence level and confidence intervals. Okay. The wider. Okay. So I'm repeating it multiple times because this is very important. Okay. Higher confidence level result with a wider confidence interval. Okay, wider confidence interval. Okay, so in this case, in our case also, okay, in our case also, if I just erase this, okay, so in our case also, what's happening is, so actually the point estimate is 48. Okay, let's say our point estimate is 48. Now we are saying 45 when the margin of error is 3. Okay, when the margin of error is 3, this is our range. Okay, see, margin of error, if it is 3, our range is 45 to 51. Agree? Now, if the margin of error is 5, can you tell me what will be the range? Tell me guys, if the margin of error is 5, what will be the range of confidence interval?
Sir, P value 50, sir.
P value 48. Point estimate value is 48 guys. And the margin of error is 5. What is the confidence level? Sorry, confidence interval.
48 minus 5 to 48 plus 5.
Correct. 48 plus 5 and minus 5. How much it will be? 53 and 43. Okay. If it is 10, 58, 38. Okay. Getting? So now based upon this error, how much you are adding or subtracting? Okay. How much you are adding or subtracting? This interval is getting clearly changed. Clear? And as I said, see, now you only tell me guys, see here. See, understand? See, మన actual population mean ఎంత? మన population mean ఎంత guys?
50.
50. మార్జిన్ 3 ఉన్నప్పుడు మన కాన్ఫిడెన్స్ ఇంటర్వెల్ ఎంత?
45 to 51.
5 ఉన్నప్పుడు
43 to 53.
10 ఉన్నప్పుడు 38 to 58. ఫైన్. ఇప్పుడు క్వశ్చన్ ఏంటంటే లిసన్ కేర్ఫుల్లీ. ఇది మనం ఎందుకు క్యాలిక్యులేట్ చేస్తున్నాము? 3 కానీ 5 కానీ 10 కానీ క్యాలిక్యులేట్ చేయాల్సిన అవసరం ఏంటి మనకి? ఎందుకంటే ఈ మధ్యలో ఎక్కడో మనకి ఈ పాపులేషన్ మీన్ అనేది దొరుకుతుంది అని చెప్పి. అగ్రి? ఈ మధ్యలో ఎక్కడో మనకి పాపులేషన్ మీన్ అనేది దొరుకుతుంది అని చెప్పి మన పాయింట్. ఇప్పుడు నేను 3 తీసుకుంటే కాన్ఫిడెన్స్ ఇంటర్వల్ ఇది వస్తుంది, 5 తీసుకుంటే ఇది వస్తుంది, 10 తీసుకుంటే ఇది వస్తుంది. ఓకే. ఇప్పుడు 3 నీకు యాక్చువల్ పాపులేషన్ మీన్ ఎంతో నీకు తెలియదు. ఓకే. ఇక్కడ మనం ఎగ్జాంపుల్ మనం ఆల్రెడీ 50 అనుకుంటున్నాం కానీ 50 అయితే అని అనుకుంటున్నాం కానీ మనకి యాక్చువల్గా ఎంతో తెలియదు, అందుకే ఇదంతా చేస్తున్నాం. ఈ 3 మార్జిన్ ఆఫ్ ఎర్రర్స్ అనేది క్యాలిక్యులేట్ చేశాం. దీంట్లో దీనికి ఒక కాన్ఫిడెన్స్ లెవెల్ ఉంటుంది. ఓకే. దీనికి ఒక కాన్ఫిడెన్స్ లెవెల్ ఉంటుంది. కాన్ఫిడెన్స్ లెవెల్ 1, కాన్ఫిడెన్స్ లెవెల్ 2, కాన్ఫిడెన్స్ లెవెల్ 3. 3 కాన్ఫిడెన్స్ లెవెల్స్ ఉంటాయి. అంటే ఏంటి? సింపుల్ వర్డ్స్లో ఈ రేంజ్లో పాపులేషన్ పారామీటర్ క్యాప్చర్ అవుతుందని ఎంత కాన్ఫిడెంట్గా చెప్పగలుగుతాం మనం? ఈ రేంజ్లో ఈ పాపులేషన్ మీన్ అనేది క్యాప్చర్ అవుతుందని ఎంత కాన్ఫిడెంట్గా చెప్పగలుగుతాం? దీంట్లో ఎంత కాన్ఫిడెంట్గా చెప్పగలుగుతాం? ఓకే. ఆ వాల్యూ ఎంత అనేది వీల్ సీ లేటర్. బట్ సింప్లీ ఇది 1 అనుకుంటే ఇది కాన్ఫిడెన్స్ లెవెల్ 1, కాన్ఫిడెన్స్ లెవెల్ 2, కాన్ఫిడెన్స్ లెవెల్ 3 అయితే ఏ కేసులో మీకు ఎక్కువ కాన్ఫిడెంట్ ఉంటుంది? జస్ట్ థింక్ అండ్ సే. ఏ కేసులో మీరు దీంట్లో పాపులేషన్ పారామీటర్ క్యాప్చర్ కావడానికి ఎక్కువ ఛాన్స్ ఉంది వెన్ కంపేర్ టు అదర్. సో ఈ ఆర్డర్ అనేది ఏముంటుంది చెప్పండి?
థర్డ్ వన్ లో ఎక్కువ
ఉంటుంది. వై?
ఎక్కువ రేంజ్ ఆఫ్ వాల్యూస్
ఉంది. పర్ఫెక్ట్. ఎందుకంటే మనది ఈ మూడిటికి మన పాయింట్ ఎస్టిమేట్ ఏంటి? మన యాక్చువల్ పాయింట్ ఎస్టిమేట్ ఎంత? No,
Sorry, 48.
I think you're confusing. Don't confuse with 50 అనేది mean, population mean. Point estimate ఎంత?
48.
48. Okay. ఈ మూడిటికి పాయింట్ ఎస్టిమేట్ 48 ప్లస్ ఆర్ మైనస్ ఈ వాల్యూస్ వచ్చినాయి. సో 48 దగ్గర నుంచి మనకి ఈ రేంజెస్ అనేది క్రియేట్ అవుతున్నాయి. ఓకే, ఈ రేంజ్ అనేది మనకి ఇంక్రీజ్ అవుతూ ఉంటే ఆబ్వియస్గా మన కాన్ఫిడెన్స్ అనేది పెరుగుతుంటుంది. అగ్రి? మనకి జస్ట్ 48కి ఒకటే ఇప్పుడు మార్జిన్ ఆఫ్ ఎర్రర్ అనేది 1 ఉందనుకో, అప్పుడు ఏమైతే వాల్యూస్ మార్జిన్ ఆఫ్ ఎర్రర్ ఈక్వల్ టు 1, అప్పుడు వాల్యూస్ ఏమైతాయి?
47, 46. 47, 49.
కరెక్ట్, 47, 49. ఓకే, ఈ 2 వాల్యూస్ వస్తాయి. ఓకే, ఇక్కడ మధ్యలో పాయింట్ ఎస్టిమేట్ ఉంటుంది. పాయింట్ ఎస్టిమేట్ అనేది ఎప్పుడు సేమ్ ఉంటుంది. ఓకే, ప్రతిదానికి పాయింట్ ఎస్టిమేట్కే వీళ్ళు ప్లస్ ఆర్ మైనస్. ఓకే, ఇది మారదు. ఓకే, సో జస్ట్ 1 ఉంటే 47, 49. సో మనం అంత కాన్ఫిడెంట్గా ఉండము, ఎందుకంటే 48 మన పాయింట్ ఎస్టిమేట్, దానికి జస్ట్ ఒక వాల్యూ ఇటు వాల్యూ అన్నా కూడా మనకు అంత కాన్ఫిడెన్స్ అనేది పెరగదు. ఓకే, బట్ ఈ రేంజ్ అనేది పెరుగుతూ ఉంటే 45 to 51 అయింది, కొన్ని ఎక్కువ వాల్యూస్ ఉన్నాయి, ఛాన్స్ ఎక్కువ ఉంటుంది. 43 to 53 అయింది, ఇంకొంచెం పెరిగింది. ఓకే, కొంచెం ఎక్కువ ఉంటుంది. 38 to 58 అయింది, అందుకే 38 to 58. ఓకే, మనకి చాలా వాల్యూస్ ఉన్నాయి. సో ఖచ్చితంగా ఇంత పెద్ద రేంజ్లో ఎక్కడో ఒక దగ్గర మన పాపులేషన్ మీన్ అనేది విచ్ ఇస్ మ్యూ అనేది ప్రజెంట్ కావచ్చు అని మనకు కాన్ఫిడెంట్ ఎక్కువ ఉంటుంది. అర్థమవుతుందా?
Yes, sir.
కరెక్ట్. సో అందుకు ఇప్పుడు ఈ ఆర్డర్ ఏంటి? విచ్ విల్ బి గ్రేటర్ దెన్ విచ్? CL1 అనేది అన్నిటికన్నా హైయెస్ట్ ఉంటుంది. అగ్రి?
లోయెస్ట్ ఉంటుంది. CL3 లో ఎక్కువ ప్రాబబుల్.
ఓకే, CL3 will be greater than CL2 will be greater than CL1. అగ్రి? రేంజ్ అనేది ఎక్కువ ఉంది కాబట్టి కాన్ఫిడెన్స్ లెవెల్ అనేది ఎక్కువ ఉంటుంది. ఓకే, సో సి నీకు ఇంకొక ఎగ్జాంపుల్ చెప్పాలంటే దీంట్లో మనకి విడ్త్ అనేది ఎక్కువ ఉంటే కాన్ఫిడెన్స్ అనేది కూడా మనకి ఎక్కువ ఉంటుంది. అంటే ఫర్ ఎగ్జాంపుల్ ఇప్పుడు మీకు లెట్స్ సే యు ఆర్ అట్ ఏ హైట్ ఆఫ్ 10 meters. Okay, height of 10 meters. Okay, so now if I ask you to walk on a okay wood, okay, ఒక wood plank ఉంది, దాని మీద walk. if width is like for example 5 feet, okay, 5 feet width ఉంది, దాని మీద వాక్ చేయమంట, కాన్ఫిడెంట్గా చేస్తారా? చేస్తారు. ఓకే, కాన్ఫిడెన్స్ లెవెల్ ఉంటుంది. 4 feet అయింది విడ్త్, కొంచెం సన్నగా అయింది, కాన్ఫిడెన్స్ తగ్గుతుంది. ఓకే, 3 feet, 2 feet, 1 feet, హాఫ్ ఫీట్, ఈ విడ్త్ అనేది డిక్రీజ్ అవుతూ ఉంటే మీ కాన్ఫిడెన్స్ కూడా డిక్రీజ్ అవుతూ ఉంటుంది కదా. గెటింగ్? ఎందుకంటే చాలా విడ్త్ ఉన్న వుడ్ మీద వాక్ చేయాలంటే ఈజీ, ఎందుకంటే పడిపోయే ఛాన్సెస్ తక్కువ ఉంటాయి. ఈ విడ్త్ అనేది సన్న చెక్క లాంటిది, అది ఇఫ్ ఇట్ ఇస్ డిక్రీజింగ్ దాని మీద వాక్ చేయాలంటే ఆబ్వియస్లీ యువర్ కాన్ఫిడెన్స్ విల్ డిక్రీజ్. అగ్రి? సిమిలర్లీ ఇక్కడ కూడా ఈ విడ్త్ అనేది తగ్గుతూ వెళ్తుంటే మీ కాన్ఫిడెన్స్ కూడా తగ్గుతూ ఉంటుంది. సింపుల్ పాయింట్. ఓకే, సో అందుకే ఈ యొక్క లైన్ మీనింగ్ అంత ఉంటుంది. హయ్యర్ కాన్ఫిడెన్స్ లెవెల్ రిజల్ట్ ఇన్ వైడర్ కాన్ఫిడెన్స్ ఇంటర్వెల్. ఓకే, ఫైన్. సో దాని తర్వాత వాట్ వి జస్ట్ స్టడీడ్. సో గెటింగ్ బ్యాక్, అవర్ హోల్ కోర్ కాన్సెప్ట్ ఇస్ టు క్యాలిక్యులేట్ ద కాన్ఫిడెన్స్ ఇంటర్వెల్. ఓకే, దట్స్ ఇట్, టు క్యాలిక్యులేట్ ద కాన్ఫిడెన్స్ ఇంటర్వెల్. సో ఇప్పుడు కెన్ యూ టెల్ మీ వాట్ ఈస్ ద ఇంపార్టెన్స్ ఆఫ్ కాన్ఫిడెన్స్ ఇంటర్వెల్? ఎందుకు క్యాలిక్యులేట్ చేస్తాం కాన్ఫిడెన్స్ ఇంటర్వెల్? దాని నుంచి ఏమొస్తుంది?
To get range of values so that we can get exact value from that range.
No, we'll get the range of values, that is correct. But what is our goal? Our expectation is to capture the
Mu.
Mu is what?
Population mean.
Correct. Okay, that is the point. To get a range of values, confidence interval is to get a range of values so that we can capture this mean. Okay, this mean we want to capture here. Okay, so that is the point. So now to do that, obviously I said there are two ways. Okay, one is population point estimate with margin of error. Okay, so this margin of error I have already explained 2 times. Okay, so you will have an formula. Okay, just but the main formula is x bar plus z into alpha by 2 into square root of n. Okay, now what is this x bar? X bar is sample mean. Okay, x bar is sample mean. In our case it is point estimate. Okay, in our recent example this is 48. Okay, and this row is population variance. Okay, the actual population ఏదైతే మనం కన్సిడర్ చేసామో దాని వేరియన్స్ ఒకేలా row అయితే you will use this. Why? Because this formula will work only if the population variance is known. Okay, otherwise there is another formula, we'll come to that. Okay, and n is a sample size and z is a critical value, we will see. Okay, there are few values. Okay, now this formula, let me know if this is clear. Okay, this is just from the deriving from the point estimate plus margin of error. This is point estimate, this is margin of error. Okay, so is this formula okay to you?
Yes, sir.
Okay, fine guys. Now there is one very important concept with this alpha. What you are seeing, this alpha, this is actually very important. Okay, so we'll try to understand that. See, focus here. Now we use multiple terms. Okay, I said confidence interval అని చెప్పాను, confidence level అని చెప్పాను. Okay, point estimate అన్నాను, margin of error అన్నాను. Okay, all these are fine. Now let's focus on these two, confidence level. Okay, and for each confidence level you will have a confidence interval. Okay, that's fine. But అంటే ఏ రేంజ్ తీసుకున్నా ఈ ప్రతి రేంజ్ ఇట్ ఇస్ కాల్డ్ as confidence interval. Range అంటే interval, remember like that. Okay, you are having a range, that is interval, and each interval you should have some confidence level. That is fine. But from this only each confidence level, okay, for each confidence level there is something called as, there will be something called as level of significance. Level of significance. Okay, that is alpha. This alpha, what you're seeing, is called level of significance. This is very, very important, guys. Okay, you will see this many times. Alpha is called level of significance. Now confidence, the relation between this confidence level and alpha, okay, confidence level equal to 1 minus alpha, guys. Okay, or in a better way, first you can understand this as confidence level. What are the confidence level you are going to take plus alpha will always be equal to 1. Okay, always be equal to 1. And what is this we'll see. If at all you want to calculate, you want to go for a 95% confidence level, guys. Okay, so we are going to see examples, everything. Okay, don't worry, but I'll give you a general idea. See, you have calculated the point estimate. Okay, everything is fine. Now you want to calculate this range. As I said, for every confidence interval there should be some confidence level attached to it. Do you agree? For every confidence interval there should be some confidence level associated with it. Agree or not?
Yes, sir.
Agree. Now for this confidence level you can decide ఎంత కాన్ఫిడెంట్ గా చెప్పాలనుకుంటున్నావు. 90, I am 90 confident, 95% confident, 99 confident, 80 confident, that is your wish. Okay, but here let's say for example you are 95% confident. Okay, for a 95% confidence level of 95% confidence level. Okay, so then from here alpha is what, guys? 1 minus CL. Okay, so at a 95% confidence level, okay, that means if this, but no, if you want to give this interval, whatever the interval you are giving, you want to give it as 95% confidence level. So this will create alpha is 1 minus 95% means what? 0.95, which will be equal to 0.05. Okay, 0.05. Agree? So this means we are proposing a confidence interval. This confidence interval I am proposing with a 95% confidence level. Okay, with a 95% confidence level, and the level of significance is 0.05. Okay, why we want to calculate this level of significance is I'll tell you. So with this level of significance only, you will have this parameter called as z at alpha by 2. Okay, z, whatever the value you want, you need to calculate this critical value. What is this z, guys? Critical value. What is this critical value? I think this is not new. From the z tables, okay, in the normal distribution, using z tables, we have calculated the area values. You remember? So it is from there you need to pick up the values from the z tables. Okay, but at what value you need to pick up? Okay, because in the z table, z at normal distribution, if I quickly go to z table, yeah, so z score. So at what value you want to do? Okay, if you wanted 1, fine. So if you remember how we did this, okay, if it is 1.05, so it will be 1.00 plus 0.05, fine. And from the z table you will calculate 1 and 0.05, and wherever it is matching, you will consider that value from the z table. Do you remember this, guys? How to use the z table?
Yes, I remember.
Forgot?
No, remember.
Okay, so obviously you need some value from z table. If you want to pick up some that value is nothing but the area or the probability which we discussed, right? So to get some value, at what value you want to calculate, right? So you need to have certain value. Okay, so here also from this formula, you know everything. You know x bar, you know rho, because population variance is known. Okay, and you also know number of samples. The only thing is z. Okay, now z alpha by 2 means take the z value from the z table at what? At alpha by 2. At alpha by 2. Now what is this alpha? Alpha is nothing but very simple. It's called level of significance. And from where you are getting the level of significance, the relationship of level of significance is with the confidence level. What is the relation? See, confidence level plus alpha is 1. Okay, confidence level plus alpha will be equal to 1. Simple. Okay, and that means alpha equal to 1 minus CL. Now the whole concept here is, okay, from the starting of this class, we are trying to try to find out one thing that is called confidence interval. Okay, so confidence interval, and what is the scope of the confidence interval? To capture the population mean. That is the concept. To capture the population mean is the idea to calculate the confidence interval. Okay, and how we are going to get this now this is the point here is, I am going to calculate the confidence interval. That's fine. Okay, నేను confidence interval calculate చేస్తాను, but ఎంత కాన్ఫిడెన్స్ on calculate చేస్తాను, that is the confidence level. Agree? See, this point what I'm saying is important. You are calculating the confidence interval, but confidence level ఎంత? That should be the first question. Okay, without any confidence level, you cannot say the confidence interval, guys. Okay, so ఎందుకంటే I'll just say this is some confidence interval. Okay, some range, but if I don't give any confidence level, ఇది ఎంత అని ట్రస్ట్ చేయాలి? Because if this confidence level is 10%, I will not use this only. 10% confidence level తో నేనేం చేసుకోవాలి? Are you guys getting?
Yes, sir.
See, understand this point. నేను ఒక కాన్ఫిడెన్స్ లెవెల్ ఇస్తున్నాం. Okay, for example, if you ask me, Megan, if you ask me, sir, tomorrow when you will start the class? Okay, so I'll say I'll join at 6 o'clock, but with a confidence level of 2%. Will you join the class? No, because confidence level is 2 out of 100. It is 2. That means mostly I'm going to miss the class. Getting? But if I say I'll join, hey Sirisha, I'll join the class at 6 o'clock, but with a confidence level of 99%. So will you join the class?
Yes, sir.
కరెక్ట్. సో అందుకే కాన్ఫిడెన్స్ లెవెల్ అనేది ఖచ్చితంగా ఇంపార్టెంట్. వాల్యూ అనేది నేను చెప్తున్నా, కానీ ఎంత కాన్ఫిడెన్స్ అని చెప్తున్నా, దట్ మ్యాటర్స్. ఓకే, ఐ పాస్, అదొకటి, ఐ డెఫినెట్లీ పాస్. I'm sure that's why in our normal language also, if you observe, we will use this without knowing consciously. 100% confident. Are you able to relate? I'll say 100%. I'm 100% confident that I'm going to pass, or I'm 100% confident that India is going to win. Are you able to relate? In our normal English language also, as we speak, we use these terms without knowing. I'm confident. I'm this much confident, that much confident. Okay. So that's why confidence level. So everything should have some confidence level. Otherwise, it will just say words. Okay. So that's why here also, for this confidence interval, for this confidence interval, there should be some confidence level. Okay, that you need to decide. So now the scenario here is I'm guessing 95%. Okay, you can take anything. Okay, so I'm taking 95% confidence level. Okay, 95% confidence level నేను assume చేసుకుంటే, okay, from there I'll get this confidence interval. Okay, but how? This is a chain reaction. If you decide 95 as a confidence level, the alpha will be 1 minus CL. That means alpha equal 1 minus 0.05, 95%, 0.05. Alpha is 0.05. Now go here, take this formula. X bar you already know. Z at alpha by 2. That means what is alpha? 0.05. Now 0.05 means this will become 0.025. Okay, 0.05 by 2. Okay. This calculate the Z value at 0.025 and rho n, put this, you will get this value from X bar plus or minus, do that, you will get a range, that is a confidence interval. At what confidence level? Tell me guys, at what confidence level I am proposing this confidence interval? This is 95. Okay, that is a concept. You can change this. For example, see, I'll show you one more scenario. You want, hey, I don't want 95%, I'll just 90. Okay, so my confidence level is 90%. Simple. From this, how much will be the alpha, guys? Alpha is 1 minus CL, that is 1 minus 0.09. Okay, 1 minus 0.09 or 0.9. Oh, 0.9. Okay, so 1 minus 0.9, 0.9 or 0.90. Okay, that means this will be 0.1. Okay, so for a 90% confidence level, you will get a 0.1 significance level, 0.1 alpha. Getting? Now you got the alpha. Go here, do alpha by 2. Alpha by 2 will be what? 0.05. Yeah, 0.05. So at 0.05, calculate the Z value, replace these values, do X bar plus or minus, you will get a range. And that confidence interval is, so that confidence interval, whatever I'm going to get, I'm saying, hey, I'm proposing this confidence interval so that you will capture the true population over here, but with a confidence level of how much, guys?
%90.
90%. Okay, like that. So as you can see clearly, changing the confidence levels is clearly changing the confidence intervals. Because why? Because if you change the confidence level for 95, the alpha is 0.05. For 90, the alpha is 0.1. As you change the confidence level, the alpha is clearly changing. Agree? Agree, right? If you change confidence level, alpha changes. And if alpha changes, what will change? Z changes. Agree?
Yes, sir.
If Z changes, what will change? This whole parameter will change. And what is this whole thing? This is confidence interval. Agree? So this will be new confidence interval. This will be new confidence interval. So the confidence interval is always dependent on the confidence level. Change the confidence level, you will get a new alpha, which is level of significance. With new alpha, you will get new Z. And with new Z, you will get a completely new confidence interval, and it is with the corresponding confidence levels. Okay, fine. Yes, so that would be the concept, I would say. So from this only, so which one to calculate and how to calculate and what will be the values, how the population mean will be captured. Okay, so I'll be explaining tomorrow. Okay, so but I hope the concept is clear. Okay, most of the concepts that we covered today are already covered in the previous class, but still I would like to cover because we got some gap, right? So because these are very important concepts, I don't want you to miss or have half understanding. So that's why I took some time and revised. But I hope that conference level so but tell me, is conference interval, conference level of significance and this formula, is this concept clear, at least at a high level?
Yes, sir, clear.
Okay, so tomorrow we'll see a practical example where it will be very much clear. Okay, so tomorrow we'll see a practical example, and with this diagram it will be very, very clear. Okay, don't worry. Fine. So as I said, yeah, so there are few concepts pending, guys. So I'm planning to wrap statistics, okay, by this month end or mostly weekend. Okay, if I possible, I will take 1 or 2 days from December, or mostly I'll wrap. Okay, there is one important concept called as hypothesis testing is pending. Okay, but yeah, trust me, once this statistics is done, right, this might be bit time taking or bit difficult to understand. Okay, but I am glad that you guys are following, okay, and understanding. So once this is done, right, so then we are going to have a super interesting concepts which we will be starting the core of data science, like NumPy, Pandas, Matplotlib. From there we will jump into the actual machine learning, feature engineering. All these concepts will be actually very, very interesting. My actual interesting area in the data science is this part. So right, so this, but strategy is very much important, but it just requires more focus. Okay, but glad we are covering it like in detail. Okay, and once we wrap up this, right, so then it will be very much interesting and exciting. Okay, so yeah, the plan is this, and yeah, so let's join without fail, okay, again from tomorrow, so that we'll close this on time, this module. Okay, fine, guys. Okay, so just go through this class once again, and tomorrow we'll see the practical example of confidence level, interval, and level of significance. Okay, so that should be very helpful. Sounds good. Okay, are we good?
Yes, sir.
Cool. Thanks, guys. Thanks for joining. Let's meet tomorrow. Thanks. Bye.